And lastly, I'd like to say thank you to Mott McDonald for letting us use their venue. Thank you for Daikin for sponsoring refreshments. And thanks to everyone who helped to organize this event. And the reason why we're here is to hear about embodied carbon in New Zealand industry. We have two amazing speakers lined up. First, we'll hear from Nick Harmon, who's the technical director at Mott McDonald, followed by Ryan Fields, who's sustainability lead at Daikin. Each presentation will take around 20 minutes, followed by a Q&A session. So without further ado, please welcome Nick.
Put the timer on.
Seamless.
Awesome.
There we go.
Cheers. Okay, good everyone. So yeah, Nick is my name, and I am going to do some scene setting, try and start right out here before we start talking about body carbon buildings, split into operational and embodied, and then we go diving down the branch of embodied, down to services, and then we'll talk about that a little bit, and then we'll hear from someone who's much more cold face to that, from Ryan, and then very keen to use the Q&A opportunity that we have to hear from some other people in the room on their experiences, questions, and etc. So, cool. The biggest picture, which is the world versus climate change. I really like this image. I think it just captures a lot of perhaps what we were all kind of going through 2020, 2021, wrapping our heads around this stuff. But we're now up against the big opponent, climate change, and I call this the ski slope graph that our emissions need to go down. It's like those crazy Winter Olympic ski jumper guys. This is the kind of trajectory we have to go down. And is it the yellow line? Is it the maroon line? Is it the purple line? We can talk about which one of them is, but the end goal is the same, and there's some slightly different outcomes based on which curve you run. But that is just to be clear, that is needing to be by the halfway point between 2020 and 2050. We need to be more than half of the emissions, not just in the built environment, but in everything, everywhere. We need to be more than half. So you can see that we need to reduce emissions quicker than just the linear line, ideally. Excuse me, right on the throat. And we certainly don't want to go anywhere near that dashed blue BAU line. So for embodied carbon materials stuff, concrete industry, steel industry, they've all got these roadmaps to take that route to zero. Most of them are a fairly linear line. So how do we as designers and specifiers and builders take up the gap to get to more than 50% to below the linear line? That's something that needs everyone's full efforts pulling in the same direction to achieve, because it is a massive challenge that's been thrown down, and it's at a high level a legal requirement at a country level. Obviously the legalities of exactly the detail of how we achieve that differs from political season to political season, as well as changing scenes in terms of information we have. But there's lots of acronyms listed down the bottom, which are all kind of industry or influential organizations. You've got Envy Brands. MECLA is a really interesting one to have a look at, to Google later. It's the Materials and Embodied Carbon. I forget what the L stands for. Alliance. Leadership Alliance, I think it is, doing a lot of collaborative work around this, not just for services and structure, but for all sorts of things. And more and more is coming into the space every year to try and coalesce towards what 20% of which we're trying to influence at a national level. And if services are 20% of that 20%, then that's a big chunk. There's a slide I had from ages ago, which is just some quick maths to show that if we wanted to plant our way out of the problem we would have plant our entire existing agricultural land mass in forest this year, and that would sort us out for next year's emissions, and that's it. So this is not a silver bullet. This is far from a silver bullet. So we need to focus on, actual innovative change, and not just trying to do what we always do and plant our way out of it. Cool. That's the overall carbon global thing. Now, buildings got stuff and we've got energy. I think you will all, and as an industry, the people that CIBSE represent have been doing heaps of great stuff around operational and energy demand and in-use carbon for a long period of time. But the stuff that, as it pertains to the carbon equation, has been kind of neglected for a while. And so here's a really confusing slide. But the key message is that those little pies over time, the mix of operational energy to embodied energy that's associated with buildings, that mix changes over time as we go forward into the future and the grids decarbonize and things. So embodied becomes a bigger bit of the pie, and everyone who works in a building engineering firm influences all of that to varying degrees. The upfront capital carbon is the main chunk of embodied carbon, and that's defined as those LCA modules there. I like to think of it as everything that goes from raw material in the ground out into materials and products to site, assembled, ready to go for the ribbon cutting. So I kind of think of upfront capital carbon as all the carbon that's associated with what we do, design and build, up until practical completion, up until ribbon cutting. And that's that big part. Do I have a laser? Second on right there. No, laser's not working. It's the big practical completion blip, right? So that's why there's a lot of minds focused around that. And then, so this is just a different representation of the previous one in terms of modules A, B, C. You've got A's, which is that very initial upfront carbon. And then you've got some operational in yellow and some embodied in pink over time as you replace stuff and as you use the building. And there's an end of life piece at the end. So we're going to talk about, and when we talk about embodied, we'll talk about the pink bits. And obviously for services, there's their own particular mix of how big a spike there is associated with the services system in a building at the beginning, and how many spikes and how big they are over time. So that's kind of some of the more specifics that we'll get to, but I just wanted to cover off before we get to services, what about our building engineering colleagues? This is more my original background, structure, foundation, facade. So what are they doing? How are they capturing the embodied carbon associated with everything that comes together for a building? Looks like a lot of stuff, eh? But I just want to talk you through a quick, so this building in Auckland, prelim design, look at a couple of options for structure, facade and fit out, structure, facade and foundations. It's a cross section, it's not an insubstantial building. What did we have to do? Oh, actually, we just had to figure out 17 lines of this is how much stuff is in the foundations, the structure, and the facade. Pretty easy. Took us a day, and captured a heck of a lot of carbon for that building. Plugged it into a tool which converted the material quantities into some carbon, a trusted tool from Brands, and then another trusted tool from the New Zealand Green Building Council. Cool, okay. But you're probably quickly realizing that to do the same thing for a significant bit of services plant, probably the same number of data points, not insignificantly similar amount of thinking that has to go into, okay, well, what's going into that? Where did that come from? How did it get to site? And how often do I have to replace it? So whilst the scale of the physical thing that you're thinking about is a lot smaller, the thinking you have to do is quite similar, and the effort you might have to go into to produce a quantities list and then a carbon number out of that is actually similar to what we have to do when we're looking at that whole big massive thing. So that's some of why services are harder because you have to do that multiple times. But an example of what that came to, and what you're able to learn from that by doing that, and of course if we had some services values to tip on top of these, some chunks to sit next to this that represent the services, well, we'd think differently about the entire project as well. So how do we get that missing chunk? So there's some estimate methodologies out there based on some small sample size studies. I think everyone will recognise that the sample size studies for this stuff is quite limited in terms of projects that have actually done the money to do that work, to do that 17 lines for as many of the bits of the service system as you can. Distribution systems, not so worried about. Pipes and ductwork and stuff are a bit more simple, but the actual plant work, there's some numbers kicking around on the screen, sort of 50 to 75 kgs of carbon per square metre. Okay, put in context of that 500 kgs of carbon per square metre that was structure, facade and foundations. Okay, it's 10-15% maybe of that number again. So, in a world where we need to do everything to get everything down as low as we can, as soon as we can, that's worth capturing, eh? And the big thing to see here is that the use phase embodied carbon from refrigerant loss is potentially quite significant. And also there's more use phase carbon from replacement. So this is a nice diagram so that the easier to do stuff is the more permanent, less replaced stuff. And these things that do a bit more leapfrogging over the life of the building require that thinking around replacement. Okay, when we replace it, are we replacing it with the same thing or replacing it with something different? Is it going to come from the same place as the thing that I put in there? Or is it in 15 years when I replace it, is it going to come from somewhere else? Those things are a bit more significant when you're talking about potentially 3 replacements in the life of the building as opposed to, 1 or none. And there's a huge amount of complexity that goes into producing services, plant work, bit of gear. So tracking all of that down or get a number is a bit difficult, but it's not impossible. And there are some methodologies out there for it. If you've come along to this talk interested in this topic, I'm going to assume that you've heard of TM65 and have possibly even opened it and have had a little look at it. You might have gone 40 pages. It's quite a lot. I have a deadline to get out. Could someone give me the summary? Okay, here's the real quick summary. Is you need the section A basic calculation method information. Otherwise, you can't go any further. What does section A look like? You need basic breakdown of the materials that make up, 90 to 95% of that thing. And what you'll find is that even that information is very hard to get from a supplier. But this gives you a framework for what you can ask for, and it gives you a framework of what you could make some estimates with, even if you only had partially complete information. And it gives you a framework for, as you collect more and more of these bits of information, you can start to see some trends, you might pick up some patterns, you develop your own understanding and knowledge about it, so you're less like just fumbling around in the dark and you've got a few things to kind of hold on to as okay, well, I don't know what that is, but I know what it might be. And you can work through a very basic calculation that takes you to, okay, in this instance for a heat pump, 12.2 tons. Figure out front and body carbon for that bit of kit. 12.2 tons is quite a lot. That's more than the considered average for a single Kiwi citizen's annual footprint from all the other lifestyle choices. So for 1 year, not a small number. And we do this little refrigerant leakage and end of life refrigerant check, and the number goes up 10 times to 120 tons. Oh, right, that is getting pretty significant. There's some stuff in the top right hand corner, which there's a New Zealand Australian annex to TM65, which has some, I think, fair to say, higher refrigerant leakage rates that they suggest as the given default rates. They can be, you can, if you have better information, use different ones, but that's part of what drives quite a big number here. Of course, if you didn't get that basic materiality breakdown, you're just like, you're not even starting on the board really. There's not much to go off. So that's why those very coarse spread square meter rates are quite appealing at the moment, because even if you can get some of those material breakdowns for 10 of the large number of bits of kit that are in your building, if you can't get a large chunk of them in that materiality breakdown, you can't really feel like you're capturing a significant amount of them. So you're going to always do a blend of permissible rates and specific ones. So anyway, it needs everyone kind of asking for this information, working it out, sharing it back, slowly building up the data. But while we stay in low data land, the fundamentals of less is best remains, right? Stuff, the concrete and steel and copper and plastics, less stuff, less distribution systems, less systems will perhaps not quantifiably, but not quantitatively, but qualitatively, will be a lower amount of services stuff in the building, leaving more available to be used for others or to not be used at all, hopefully. And then refrigerants is this really big industry issue that I don't think anyone's got the right answers to or the full complete picture of, but it's a key area for more specific dialogue, research, and sharing. Just want to quickly plug a brands tool which is useful for part of this conversation or on this subject. It's called LCA Play, and it's kind of geared to giving these course estimate efforts, course estimate assessments to compare scenarios against each other. The blue, orange, grey is focused just on the embodied of the structure and facade and the ground slab, and the one on the right is when you bring in operational carbon as well. It's all about figuring out the delta. This is very basic systems, facade services, structural systems, and some building geometry building geometry values that you can play with. Really interesting tool for demonstrating that you can generate some quite different outcomes for a building that might still have a very similar amount of GFA, but might be built out of different things or might have a different servicing approach. This doesn't currently include embodied carbon of the services system specifically within it, but it's still useful for driving the conversation. So have a look at that if you haven't downloaded that. And then this is a slide, this is a favorite diagram of mine, just trying to capture, while we're not operating in a high quality, high volume, high accessibility data land, we have to operate with a bit more intuition and the right mindset. And for me, that diagram captures some of the mindset that we want to be shifting to, which is whenever we make a design decision, how does this affect costs? How is this going to affect my project timeline? How does this affect my projects, both operational and embodied carbon? If you're not asking the question, at least having a little go at estimating what option 1, 2, and 3, how they rank on a high, low, medium scale, then you're kind of missing quite a key metric, especially for any of the buildings you're working on that are doing Green Star or a rating system where quantifying that carbon is going to be required. And I like to say that just because we can't estimate carbon well for services for embodied carbon doesn't mean we can't have an estimate of it and track that estimate over time. If pushed, I don't think our QS friends would say that they can track cost perfectly or they work off perfect cost data either. There's always an element of unknown to that. We still do it because we try and track it over time. That's how we know what direction we're going in, and how we know what choices we're making between high, low, and medium cost. Similar mindset can be applied to carbon. And that's me hopefully having gone from here to a much more quite specific conversation. And I'll let Ryan take over and we have questions at the end. 1 minute under allocated time. Love that. Sure.
All right. Thank you, Anna, for setting this up, and thank you, Nick and Mark McDonald, for hosting and the previous 20 minutes. I'm Ryan, so the sustainability leader at Daikin New Zealand. Back my colleagues, I've got Ivan and Maria, so engineering and specification team. If there's any really technical questions here, please do direct them to those two, and hopefully they can help answer, because it can be quite a complex conversation with lots of difficult kind of questions, and it's all about trying to learn together. So we really do encourage dialogue. If you don't know who we are, then hopefully this next slide is going to help. We are a heat pump manufacturer, but I'd like to spend the first slide just talking to you about kiwi fruit. So zespri, and forgive me for being an immigrant here who hadn't really understood how prevalent zespri were, but they are very well known, and have done some brilliant work around food and carbon. So zespri in 2017 released a whole assessment documentation, well, published their research after doing a detailed assessment about what is the carbon footprint associated to their food. So before I go on to that, I'd just like to ask a couple of questions, just by show of hands. Who here in your day-to-day jobs within work would like Daikin, or insert name of your favorite brand, to provide EPDs? Cool. I'm really pleased that a few of you didn't raise your hands. Brilliant. So, how keep your hands up. And now, how many of you, and do raise your hand now if you didn't raise your hand before, how many of you, I love that people online are putting their hand up. And how many of you, hands up, currently use EPDs in your work?
I can't have the hand.
Yeah. Or try to where possible. Yeah. So some of the hands would have dropped, but generally there's it's fair to say quite a lot of us want more kind of embodied carbon data and EPD data, etc. But it isn't readily available for us to either actively use, or maybe there's different drivers as to why we're using it or not. So let's talk about our products. The calculated, and I'll go into kind of how that's calculated, carbon footprint based on CIBSE TM65. This is a UK data and it's estimated, but 26,463 kg of CO2 equivalent. And that's for a unit which is 317 kg. Of those of you who do use EPDs, is that good or bad? Anyone? Hands up if it's good. Hands up if it's bad.
It is.
Anyone want to say why they didn't raise their hand? Okay, well, the truth is, it's not good or bad, it's just data, right? Environmental product declarations are just declarations. We're not saying this is a really good product, you should absolutely use it. And we're not saying it's a really bad product, you can't use it. The key is to get accurate, transparent data so that we can compare things. So at 317 kg, we're talking about roughly 83 kg of CO2 per kg of weight for the VRB unit. So therefore, a VRB unit is about 41 to 42 times more carbon intensive than the kiwi fruit. Alternatively, if you use one of our VRB4 condensers, then you can eat about 13,000 kilograms of kiwi fruit. What zespri have done really well is also, as part of their research report, has actually highlighted how that fruit compares to loads of different alternative products, foods, etc. So actually now you can make an informed decision about whether or not you want to eat kiwi fruit from zespri. This is kind of where we need to get to as an industry. As an MEP and HVAC industry, this is where we want to get to, so that we and other suppliers are able to provide embodied carbon data so that you, the users, engineers, consultants, architects, designers, contractors, everyone within our industry can then make an informed decision about what product or solution is the right fit. So what are some of the drivers towards embodied carbon and kind of sustainability reporting? First of all, it's worth mentioning, obviously, the green building schemes that exist across Australia and New Zealand. Green Star, Home Star, Neighbours, BREEAM is probably not so prevalent over here, but really big driving forces within the property sector, commercial and domestic. MBIE have released the Building for Climate Change programme. If you don't know what that is, I really strongly recommend that you Google that tonight, because it's coming into play theoretically next year. Next year in the New Zealand market, there will be requirements on new commercial buildings to calculate embodied carbon data and values for their buildings. The following subsequent years, from 2026 to 2029, they will be setting targets and limits. So 1 year to calculate, and then after that, they're going to actually set targets of where we need to reduce. Ambitious, but absolutely needed. You've got the Carbon Neutral Government Programme, which is targeting government buildings to get carbon neutral by 2025. In New Zealand, as it was put into law in 2021, but came into effective reporting for last year for the New Zealand climate standards. Essentially, what that actually did was targeted the top 200 financial entities in New Zealand: banks, creditors, insurers, investors, etc. They have to then disclose their emissions. If you work within the building industry and you're a building service engineer, you may not fully understand what that means. If you're a climate standards disclosing reporting manager or something of that ilk, then you will understand actually how important that is. We all have financial disclosures that we have to report on as businesses, but this is now saying you have to also report on your climate disclosures, which looks at your, essentially the biggest area of topic is the greenhouse gas emissions associated to your business. I'll go through what that looks like in a minute, but it's really prevalent. Australia has a similar thing, which is coming into play next year. And also stranded assets, which feeds into all of these kind of points quite nicely. But essentially, if you are not reporting and reducing embodied carbon levels in accordance with the 1.5 degree trajectory that Nick kindly kind of touched on earlier, then the buildings you're designing are going to fall out of the definition of green investments. You are not going to be able to sell, let, lease, tenant, whatever, your buildings in potentially quite a near future if you're not offering them to the right clientele, as we are seeing a change in market trends. Other than that, the point that's missing is that it's the right thing to do. So that's all the financial incentives, but it is the right thing to do for us all to reduce our carbon footprint collectively across the whole life cycle. A little bit on this and why carbon reporting is really relevant to especially the MEP industry, but especially to a heat pump supplier. Scope 1 and Scope 2 is basically everything that you own. So as a business, if you're reporting on your greenhouse gas emissions in line with the Greenhouse Gas Protocol, Scope 1 is basically anything that you burn on site. So your kind of gas, if you've got boilers, etc. But also refrigerants fall into that category of mandatory reporting, which Nick has touched on. It's a really important conversation that we will get into in a couple of minutes as to why refrigerants are super important. Scope 2 is then the indirect emissions associated to your energy use, dependent upon a heat pump, as this case in point example, dependent upon the efficiency of said heat pump, that is going to direct your scope, that is going to impact your Scope 2 emissions. And then your Scope 3 isn't always mandatory reporting within the first couple of years, but for many of the reporting entities, it is considered. And Scope 3 is then your supply chains, everything purchased upstream or downstream. So that is then the impact of the embodied carbon of our products that goes into our potential customers. Now, although the XRB only impacts 200 odd companies, there are lots of voluntary environmental disclosing entities and consultancies that exist. Toitu is probably the most widely recognised in New Zealand. They've got, having read through their reports, I think they've got some 400 plus current corporate customers. So there are 400 odd customers in New Zealand, clients in New Zealand, corporates who are voluntarily choosing to disclose and report on their climate disclosures. That includes the scope of their emissions. So whether or not they have to do it or they're choosing to do it, they are doing it. So from everyone's point of view within their supply chain, we've got to help them achieve their goals by providing credible data so that they can put that into their models to report what their business carbon footprint is. It's work, sorry. Oh, is that, it's kind of right. Oh, there's a, sorry, apologies. There's arrows, which really I should have been pressing. Kind of give that way. Sorry. So in line with your Scope 1, Scope 2, Scope 3, there are EPD, or at least environmental footprint or whole life carbon categories that feed into that, which is what these categories are. So this is a slide just kind of that Nick has already touched on kindly, but you've got your upfront carbon and your embodied carbon, or embodied upfront, and that all feeds into your whole life carbon. As an industry, or within the MEP services industry, this bit down the bottom, B6 and B7, is something that we've absolutely mastered, or at least like to think we've mastered. For a long time, it's been the conversation piece that we're very adept at having when we talk about energy efficiency, energy use, lighting, controls, HVAC systems. It all feeds into what our energy use is. So that operational carbon, we're quite good at having those conversations, and there's a lot of data available to assist with those conversations. The embodied carbon bit is, as Nick alluded to, that's something that is a bit of a grey area, quite frankly, for our industry. It's something that bricks and sticks and high carbon elements within the construction industry have been having quite a mature conversation about for a long time. So if you go and approach steel, cement or wood suppliers, they should be able to give you some credible embodied carbon data. But it is an area that we'll touch on shortly that is very complex for us. Nick, you will have heard said everything needs to happen, which is also a very rough quote associated to the film, but the UN Secretary Antonio Guterres last year said, roughly quoting that we are in a climate emergency and we need to do everything everywhere all at once. The reason that's also relevant, apart from a climate point, is to say that operational carbon is no longer not important. Every single one of these stages needs to be addressed. We are not discussing operational carbon and only discussing embodied carbon. We're discussing all of it all at once. And we need to take quick action. So here's an exploded view of two of our products, an indoor unit and an outdoor unit. It's quite a lot to it. The building that Nick showed you, I think, had 8 or 9 floors and had 17 line items. This product on the left-hand side is a wall-mounted unit, which weighs roughly 12 kg. It has 178 parts, 19 basic materials, comes from 62 different suppliers. That unit alone, the amount of data that goes into that unit is fair to say is as complex as that whole building from a structural point of view. If we look at what some of those materials are, plastic, steel, copper, cardboard, and then other. Other is a big assortment of loads of different things. Plastic, as an example, makes up 31%. Sorry, I kind of stood in your way there. Makes up 31% of the product. This includes packaging, it's worth saying. But we can't just provide a product and not packaging. So we have to, it's not like we give you the option of having our products without packaging. So we have to calculate all of it. Within plastic, that accounts for 83 different items, which comes from 26 different suppliers. We manufacture a lot of the product, but obviously from a materiality point of view, we do source a lot of that. Quite complex, I think that's fair to say. Does anyone have any comments as to what is surprising clue, what is missing that you might expect to see?
Yeah, do you?
Sorry? No.
The refrigerant? Yeah, refrigerant.
Yes, refrigerant. So refrigerant is a really big conversation point. Without eye-opening Maria answering this, anyone know why refrigerant isn't included in this? That's maybe more of a I kind of should read the room. Okay, so if you work for a heat pump manufacturer, you'd know that when we manufacture these products, the refrigerant is pre-charged in the outdoor units. So if you get embodied carbon data for an indoor unit, it's not really going to come with the refrigerant information. It's the outdoor unit. The other area that actually should be addressed is also that what you would expect to see in the outdoor unit, if I provided this for the outdoor unit, is also how much of a high impact PCBs make in the electronic componentry. So refrigerants and everything that makes up the controls are really big points for us. So if we were to produce an EPD or go down that route, how would we do it? What framework would we follow? There's a few that exist and they're all quite complicated. But from left to right, you've got PEP, EPD International and UL Solutions. In yellow, what I've highlighted is some of the things that unfortunately make, apart from just the complexity of our products, that unfortunately are a challenge that we face. So in Europe, if the PEP Eco Passport, is a pretty good framework. But unfortunately, the standards that it's carried out to are following European standards. So in terms of the seasonal performance and seasonal data and the bin profiles associated to when our units should be operational in cooling or heating and what the efficiency is not then necessarily transferable for the region in which we sit. If we look at EPD International, also follows Europe, so that's a bit of a struggle, but unfortunately uses 1 kilowatt hour of thermal energy. If you're sizing a heat pump, you size it upon the cooling or heating requirement of the building rather than the electrical power draw. So not necessarily easily transferable for us to use. UL solutions based on 1 ton of cooling capacity, but it uses ASHRAE. ASHRAE is much more applicable for the region. As you can see, there's a lot of there's a lot of frameworks that exist. They're all very detailed and very useful within the regions that they sit. For us, we are really almost putting out a call for opportunity for collaboration. We want to work with industry, we want to work with different bodies, we want to work with organisations to pull this together and create a working framework that is applicable for the region, for the products. I will just quickly say that the PCR for air conditioning machines that we should be using in this region doesn't then transfer into what construction products get used for within this region. So again, another added level of complexity. So quickly, what are some of the solutions? This is a slide just taken from NZGBC, which I think is really useful. But for us to get from standard building down to kind of net zero at a whole life carbon element, there's loads of different changes that we need to make along the lines. But let's focus for now just on efficiency and lower upfront carbon. So firstly, refrigerants, which is the thing that we've spoken about, has been alluded to throughout this. So New Zealand has a gross emissions per year of about 78 million. F-gases, refrigerants make up about 2% of that. Most of that comes from the car industry, but nonetheless, even if it's 0.1% associated to HVAC, we need to take responsibility for that. So refrigerants also feature in Project Drawdown. If you don't know about Project Drawdown, come find me after and we can talk about that. But they've got a list of global climate solutions. Project Drawdown features in 4th in terms of the most important, most impactful refrigerant management. When we look at different refrigerants, it's important to say that, yes, we want to lower the environmental impact based upon a GWP metric, but we also need to consider cost, the impact it has on the energy efficiency of the product, but also the actual thermal properties of the product, and safety. If that refrigerant was to leak, is it toxic? Is it flammable? How does that impact the occupants and the environment? A few different considerations there. HFCs are potent and do have a climate impact, so it's not to be ignored. Refrigerant management features in Project Drawdown. The reuse of refrigerants is becoming much more prevalent within the New Zealand market. Reclaimed refrigerant processed uses, they reclaim, they recover refrigerant, reclaim it for a process machine, and then you're able to reuse it. It's basically, we're talking about recycling refrigerants, but to a standard that the recovered or the recycled refrigerant that gets reused is really, it's got a lower environmental impact, but it's also to the high standard that you would be getting the virgin refrigerant for. I'm quite tight on time, so I'm going to talk quite quickly, so please bear with me. But as I say, technical questions, Maria and I can grab them later. There's AGAS, an international organisation who Dyken have partnered with. Since 2019, we've been using reclaimed refrigerant in some of our products and offering it into the industry. In New Zealand, quite a niche market where there's a lot of logistical challenges for us to overcome. So AGAS is now partnering with everyone in the industry. So this is not a Dyken specific solution. Case in point, sorry, not case in point. Point of this is to say, get onto AGAS's website, understand what their solutions look like, and on any of your future jobs, if you are using HVAC systems, preferably ours, but we won't be offended. Try to use recycled refrigerant, reclaimed refrigerant where possible, because it is better. And then operational energy, obviously, neighbours is really prevalent in New Zealand at the moment and growing. There's loads of control strategies that you can and should implement to help reduce that. Having upfront, at the moment, I think it's fair to say that we all understand that there's a bit of a underutilization or not full utilization of full capacity of what full BMS systems can do in terms of energy management, energy monitoring, and reduction in emissions. have these conversations, engage with the experts. Let's all collaborate together, make sure we've got good commission, make sure we've got good information at design stage in terms of what the client wants, make sure we're putting that through all of the contract stages so that it's getting commissioned and set up correctly, and then have those conversations with the users, use data visualization tools to help change behavior and usage patterns, and also make sure you can use that data when you've got change of tenants within an office to make sure you're now setting up the HVAC system to run how the new tenants want, and we're not wasting energy unnecessarily. So, final points. Utilize new technology and products using low GWP refrigerants where possible. Okay. Yeah, cool. Reuse materials where possible, even refrigerants. Let's try to support a circular economy. And in line with what Nick was saying about that exploded view, and like if we simplify the amount of components we're using where possible, we can look at the built environment as a building, like as a materials bank, so we can try to reuse parts as much as possible. Maximize real life operational performance is obviously really prevalent, always has been, always will be. Provide support to continuously monitor throughout the building life cycle, even if you are getting changed tenants, even if you are changing services. Industry collaboration, let's all work together. We are really keen to engage in this conversation. We know you're here for a reason. Please do reach out. Let's try to work out how we can support each other, but also support the industry and ergo the climate to actually achieve the very ambitious but necessary targets that Nick has highlighted. Thank you very much.
Speaking of collaboration, we're now moving into a Q&A session. I'd like to invite our online audience to, if you have any questions, please unmute yourself and ask it.
Run and move and play and go.
Yeah, I'd like to ask a question. Can you hear me?
Yes.
Hi. First of all, I'd just like to say to Ryan and Nick, nice presentation. Well done. You very, very briefly mentioned the words TM65, but you didn't carry on much further to do with that. One of the problems we have for the building services is data orientated as opposed to the building industry, which you did outline. And for us to actually do EPDs is at the moment nigh on impossible. Now, what you do find is that a lot of consultants and other, let's use the word organizations, have got the buzzword of EPD. But for me, when it comes to building services, they're asking the wrong question. At this time, for building services, they should be asking for TM65, ANZ, mid-calc calculation. What do you say to that?
Yeah, I'd say that basic would be fine as well. Do you want to reshare?
Yep.
So sorry, Darren? Darren. Yeah, hi Darren. Maybe the slides cut out when it got to the build bit on TM65. I did quickly run through what a TM65 basic cut looks like and what the required information to feed into the start of that is. And I would say that if we could get a large chunk of the industry feeding, providing that information around their products, such that the building services and building engineering in general and the sustainability fraternity could use that as a start point, I see that as a great outcome. And I don't think charging straight up to the EPD level is necessary. I think on the way to EPD land, people are going to have to go through TM65 basic information land first, and if they wouldn't mind sharing that with us as they go on that journey before they get to the EPD end of the line, then I absolutely think that should be what's happening.
I would just finish off the question, sorry. So I was recently at CIBSE in Australia, and we had a panel discussion on TM65 and EPDs, etc. The quick question I've got is that, I can buy, I'm a fan manufacturer. So I can buy one impeller from either EBM or Zeal or Rosenberg, whoever it may be. I can make up to 25 products out of that one fan. But now I have to do an EPD eventually for 25 products. Now, who's carrying that cost? Because me as a manufacturer, I'm not. which means at the end of the day, we're just passing on this cost to the consumer yet again.
Thank you, Darren, for the question. I think you should collaborate with Daikin.
I think I agree, Darren. Having looked through this in quite some detail at the costings, it's not cheap. So I completely agree that as industry, so manufacturers working with engineers across the board spectrum from architects and consultants down to contractors, etc., not down but supply chain view, we should all be trying to provide information, having complex and challenging conversations, but necessary conversations about what is the data that's actually required and how easiest can we provide it. And actually, I think Nick's diagram was really poignant about moving away from that triangle decision-making point of view of just time, cost, and quality. Let's include carbon in that discussion and have a really robust conversation with the client so that we are meeting their expectations, but simultaneously advising on best practice and continuously trying to move forwards. Progress is, we shouldn't let perfection get in the way of progress.
I just very quickly, just as an example of something that's happened in a different part of the building industry, but the engineered wood products, the WPMA, Wood Product Manufacturers Association in New Zealand, a while back, collaborated to create some data. I think it counts as an EPD. That is like a collective industry average product EPD.
Yeah.
That didn't give, it wasn't specific values for specific products, but it said in general for this kind of product out there in New Zealand, an acceptable data point to take that was, I don't know, the top 10% number or something, would be this, and at least sort of set a benchmark through some collaboration, and then everyone sort of shared that cost of doing that collaborative piece before having to get into costing their own individual pieces, which some of them are now doing. So it's just an example.
I can see Roger has his hand up. Maybe we can take one more question from the online and then move to our to in person.
If you're still awake.
Roger?
Anna, thank you. Can everybody hear my voice? Yep. Okay, that's great. Darren might not want to hear it, but I would refer to one of the phrases that our speakers have mentioned about stranded assets, that if your building isn't green, nobody's going to rent it or lease it soon. There's going to be a period when you are going to have stranded equipment, that if you don't have some kind of result from the TM65 basic, I believe people might well not begin to purchase your product. So I think getting ahead of the game could, for a few years, be a point of differentiation.
Thanks, Roger.
I can hear some clapping. All right. Ron, anyone has a question for Nick and Ryan?
Yeah, Peter Rickard Green from TM Consultants. It's a question for the Daikin team altogether. We've been banging around the last few weeks about refrigerants and what the heck's going to happen with refrigerants in the coming years. But how big of an issue is that compared to the embodied carbon equipment itself? What does that breakup look like? Obviously, we're not talking about entire refrigerant leakage from an entire system. But have you got a handle on what that makeup is? I can't read that, so if you're going to show us that.
Roughly grey is predominantly due to refrigerant,
Right.
and blue, everything below this line, is the kind of upfront getting into the construction site.
So what are we doing about it?
Because that's over the 50 year.
Yeah,
That's what
yeah,
it's
Those are refrigerants, yeah. So how far are we along the line of actually sorting out some different, whole separate presentation? Absolutely.
That is a really good point. So we are going to be setting up, because I know you guys you toured New Zealand, right? And I heard that was really, I think a couple of our colleagues attended that. I was meaning to.
Yeah.
It was really successful. We're looking to do a similar type thing in Auckland, Christchurch, Wellington, potentially, where we did one last year, a seminar series, and we will be tackling that in a bit more detail. But essentially, the type of refrigerant you have used obviously makes a big impact. So dependent upon the GWP, and then also dependent upon the calculation you are using. Different, as we saw, TM65 in the UK has different refrigerant leakage values for life cycle, but also at end of life in terms of recovery versus the ANZ version. Same as looking at if you go EPDs or whatever. So it's having those conversations about how are you actually going to measure your refrigerant like leakage rates and things like that. In truth, what we should be doing is actually taking a collective data set from the FM businesses and their installers to say, actually, from your logs, how much refrigerant are you topping up annually into your clients' buildings? And that will give us a more realistic data set of actually how much refrigerant is leaking, which is what, Nick's highlighting there. So we do have some data which I can share with you separately about what is actually the impact of the refrigerant in the products. But
It's just in terms of order of magnitude, the refrigerant, the GWP of the refrigerant is so much more than the GWP of the embodied carbon in the materials themselves. Is it the materials that we should be looking at now, or is it the refrigerant that we should be looking at?
everything, everywhere.
And also to this diagram, which is the refrigerant that's happening over this period of time.
Yeah.
And at the end, whereas this, which is the whole building, but the body carbon of the building services gear is part of that. It's happening now.
Yes.
And we need to be tracking down that ski slope really aggressive.
Yeah, but from a building services perspective, not whole of building perspective, well, let's just say from a system perspective, that's a refrigerant system, is it the materials that make up that refrigerant system that we should be looking at, or is it the refrigerant? That's my question.
Still, I would still say all of it, but I will say there's quite a lot of data out, generally from Europe, but which is comparing like HVAC different forms of HVAC systems, from things like chillers and VRV all the way to like the fossil fuel alternatives. And what I will say is, although the embodied carbon of fossil fuel systems generally is quite low because there's not as much complexity that goes into their products, the operational carbon is so much substantially higher that even if you are using a relatively high GWP refrigerant with a relatively high leakage rate, the overall whole life carbon is still lower compared to, on average, like your fossil fuel alternatives. So let's make sure we're moving away from. That's one thing that I will say has been in conversation that people have been scared about when there's F-gas regulations which are coming into play. We say, yes, we need to meet the quota. Yes, we need to move to lower GWP refrigerants, absolutely. But in some instances, this is impeding manufacturers and they can't catch up. And then if that leads consultants, engineers, etc., to then unfortunately say, well, there's not an alternative for us to use, so we have to use a fossil fuel alternative. That's where we need to be very clear. We need to absolutely move away from fossil fuels. And the refrigerant question is something that's ongoing, and manufacturers are all trying to innovate to look to new solutions. And it also comes down to the different applications, right? So domestic, commercial, industrial, different requirements in terms of heating levels, cooling levels, efficiency requirements, etc. So there's a different, I will say this, I don't think there's one refrigerant that you're going to see in the future. It will be a myriad of different refrigerants that you will see for the application.
One other aspect is if the amount of equipment that needs refrigerant as part of it can be further optimized. That's and that's or have the conversation about performance with the client, being like, do you really want us to keep the temperature ceiling on the hottest day of the year at this, or maybe could we keep it at 2 degrees lower than that? We might have 10 hottest days over the year. What does that unlock in terms of actually lesser amount of cooling required? And those are conversations that haven't been super popular, while the operational energy and efficiency and carbon side of things has been coming down. But when you consider the refrigerant impact in that as well, and the overall prevalence of carbon as a metric for decision making coming in more and more, I think there's an opportunity to revise that. I think even clients that if you had that conversation with them 5 years ago, they were like, no, we need this, fantastic thermal comfort environment. I think some of them are starting to question, just like we all talk about how our grid system is driven off the 2 hours in the morning and the 2 hours in the evening peak. How do we translate that topic into buildings and getting people to understand that they could make a difference to the amount of systems they need by maybe relinquishing some performance on some of those.
And lastly, that conversation needs to be a conversation that we're not just having in this room, but with everyone we're having throughout the design and construction of a project, right? Because what does GWP stand for refrigerants? global warming potential. In our systems, these refrigerants are not supposed to be released to atmosphere. They're not supposed to leak. The products aren't supposed to like. So yes, you do have some manufacturer failures, but generally leakage happens at either end of life or through, unfortunately, not perfect or not proper installation methods that can be followed. So we need to make sure that we're having that kind of support of everyone in the supply chain so that we are minimizing any potential of leakage.
Yeah. So does the building have to constantly be evaluated? So take this building. I don't know how many people were here when it first was occupied, 60, 70 people on it. I'm not sure. We've now got over 200. We've got X amount of more computers, X amount more fridges. So does the building have to constantly be reevaluated?
Well, in terms of like, is it designed to meet the tenants'
Well,
needs?
when the carbon baseline change, if you're bringing
I think
more,
Dan just got an answer potentially.
So the operational parameters, this building is illustrated, so yes, every year with neighbors, you submit the energy bills, basically, you submit a new and to maintain your rating, it's an annual renewal, yes. Yeah.
Thank you, Daniel.
Right, it's 7 o'clock. Does anyone have final questions? Right, we can also take conversation offline over drinks and nibbles.
Oh, sorry, just a quick one. Just specifying equipment. How do you know that the refrigerant is recycled?
You're specifying it, so it's up to you to.
Oh, so you just ask for it rather than.
Ask for it. So I would we can put you in touch with AGAS. I'd really recommend speaking with them. They're relatively new in New Zealand, so their ability to support every project, there may be challenges, of course, but they're still, have a conversation with AGAS and they'll see how they can support you on the job. And we can either facilitate that conversation or whatever.
would your units not be imported with refrigerant in them or not?
Yeah, they are as a base charge. So at the moment, what they're looking to do is provide the top-up refrigerant. So if you're having like a full system, there's a base charge to a certain, and then you have, so that's their initial step to develop the market in New Zealand. It's by providing that kind of trim charge. There's other areas they're looking at as well, I'm sure, but that's kind of the initial, because it's there's a lot of logistics to consider in New Zealand, given our kind of sparsely spread out. Yeah.
All right, thank you.
I'm going to stick around for a drink and some more chat. So happy to take other questions after.
I think most of us are staying around. Thank you so much for joining. Thanks to Ryan and Nick for sharing and collaborating. I'd like to leave you with a final challenge to each and every of us to give a shot at calculated embodied carbon. It's complex, but not impossible, and done is better than perfect. Any final questions from you guys?
No, just thanks for coming out on what almost the longest evening of the night with Winston solstice tomorrow or the next day, and use the second half of the year as wisely as you can.
That's good.
Thank you.